Okay, to begin with, we're talking about how to solve trig equations. Let me give you one of the simplest ones. Sine squared theta equals a half. Actually, I'm going to make it a fourth. My bad. It'll work out so much nicer. Sine squared theta equals a fourth. Would you agree that that has trig in it and that is an equation? So that's a trig equation. And so you're supposed to solve it for theta. Can you just do inverse sine? No, you can't. Because inverse sine won't take out sine squared. But don't overthink this. What undoes squared? Square root. Square root, square root. And the only problem is, people always forget this. If I just had x squared equals 16 and I took the square root on both sides, square root of 16 is only 4, period. So how come there's two answers? Because there's absolute value of x. So same idea, it's the absolute value of sine theta equals square root of 1 is 1, square root of 4 is 2, there. Now, do you get that that actually has 4 answers? Why would that have 4 answers? Because we're going to split this into two equations. Sine theta equals a half, and sine theta equals negative a half. This has 2 answers. Did you ever see me use inverse trig? Was there a single time that I said arc or that it had power of negative 1? No. So this is not an inverse trig question. So there's not a restriction to have one answer. So therefore, this is going to have lots of answers. Everybody draw the triangles in the right place, find the 2 angles, and use radians. So your answers are like, pi over 3 and 2 pi over 3, except that's not it. All right. So all students take calc. So sine is positive here and here. And then sine is opposite over hypotenuse, and this is the square root of 3. And now I'm going to go, what's across from the 1? 30 degrees, aka pi over 6. Raise your hand if you had pi over 6. Cool, that's one of your answers. Allison, what's the other one? 5 pi over 6. Good. Okay. Pritzius, why isn't that the end of the problem? Because now we got to do it with negative. Do you get, I can just go and draw it in the same axes and just like slap them in down here? Because that's where they'll be. And they're going to be pi over 6s again. Okay, so, Henry, I got pi over 6, 5 pi over 6. If I keep going to here, this was 6 pi over 6. 7 pi over 6. And the last one? 11 pi over 6. So there are your 4 answers to that question. And do you get it's all circle trig, which is chapter 12, and I said was super important, and it still is? Okay. All right. Here's another type of question that we got to talk about. Everybody write sine of theta equals 1/2. We're just going to make sure you understand what that really means. I've gave you some guidelines for solving equations in here. One is if you can factor it, you should. Is there any factoring you can do? No. Is there any fractions you could clear? Well, yeah, but it's not going to get the theta alone. You know what I mean? If I clear that, if I times both sides by 2, it's legal, but it's not going to get the theta alone. But there's one last way that I said would come up rarely, but it was graph both sides and see where they cross. Does that ring a bell? Do you remember me saying that? Graph this side, graph that side, and see where they cross. If you've never seen this before, you need to know this because this is going to come up. Now, what's y equals sine of theta look like? Well, you're supposed to know. We had a whole unit on graphing trig, so everybody draw a decent-looking trig wave. You don't even have to label all of it. Just draw me a sine wave. And Rhea, where is y equals a half? Describe it on as a graph. It's what kind of a line? A straight line? Okay, is it horizontal or vertical? Yeah, it's y equals a half. Does this look like a y equals line? No. That way. There. Okay, y equals a half. It's a line that runs like that. Do those two things touch? Yeah, in fact, do you get they're going to keep touching over? I mean, we got one answer there, 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 and if I just keep this thing going, it's going to keep happening. You know what I mean? That's why this has infinite answers. Well, then how come we usually got two answers in that trig unit? Because we restricted it between 0 and 2 pi. Do you get that would like basically make a box around it like this? And we would say how many answers are there? There's 2 because we were artificially limiting it to only the answers between 0 and 2 pi, which would have been these 2. Now what if we do inverse trig? That limits it even more. If we do inverse trig, we only take the part of sine that can pass a vertical line test, so we'd zoom in even more to just that. And that's why there'd only be one answer if we were doing an inverse sine question, because then you only consider between negative pi over 2 and pi over 2. Okay, question.
So if there's infinite answers for this, does that mean you could basically just write domain range questions for like the format of the trig?
Good question. So here's how you answer it because there is infinite answers. We just figured out the answers 2 seconds ago, and it was pi over 6. Anybody got a short-term memory? What's the other one? 5 pi over 6. So here's how you write it. You say, but I could keep adding 2 pi and go over, and I could add 2 more pi and go over, and I could add 2 more pi and go over. So you can't just say, though, plus 2 pi. It's a really easy mistake to make. You got to say plus. That implies you can only add 2 pi to it. You say plus 2 pi k. And that's our way of saying you can add 2 pi to this forever. K times. K is a constant. So if k is 0, I didn't actually add 2 pi. If k is 1, I added 2 pi. If k is 2, I actually am adding 4 pi. See how that works? So when we say plus 2 pi k, there's a reason, but it means I'm going to have infinite solutions by adding 2 pi over and over and over and over and over again. All right, so here's my 2 answers. Pi over 6 plus 2 pi k, 5 pi over 6 plus 2 pi k. What if they said, I only want the 2 answers that are between 0 and 2 pi? Well, that would have been this one and this one. I'd be done. What if they say I want all the answers? They can just add in this little, oh, by the way, you're going to have to add 2 pi a bunch of times. Then what's the last? More complicated kind? That's where this gets shrunk, this graph, it gets shrunk, and all of a sudden it does a whole bunch of loops by the time you get to 2 pi. And so you get like 1, 2, 3, 4, 5, 6 answers. 1, 2, 3, 4, 5, 6 answers. I'll teach you how to do that today too. When would anything get scrunched like that? If you had a question like this. Sine of 3 theta equals 1/2. Okay. Question?
It's a question about the k thing. Does it need to be k, or could you also use like n?
This is one of those like things that you should get used to. They call it a convention. The convention is the conventional way to do it. Just like pi wouldn't have to be this symbol. We just picked a Greek symbol and always use that, and then everybody will know. Well, same idea with k. K, it means constant. And I know C is the first letter of the word constant, but K means constant in math. And U is a special one too. Do you remember U substitutions where if you want to take a problem that's really complicated and swap it out and make it just a U, you can do that. It's called a U substitution. Well, if you were with me first semester, I taught you that. So U is the conventional letter for when you swap out something more complicated. All right, so K is the one you should use. All right, so without further ado, I'm going to do this problem because that's typical hard problem of the day. All right. Would I be able to find that on this sheet here? You know, you remember the identity sheet? Do you think 3 theta was on there? No. Do you remember the double angles? Yeah, those were on there. So if it was sine of 2 theta, then I'd go grab it off the sheet and just go like, oh, I know that one. And I actually have that one memorized. It's 2 sine cosine. But this is not like that. No. You know why? Because it's not on the sheet. We don't have a nice swap for 3 theta. So, big picture, what's happening is what I told you before, that sine just got squished. It seems like I stretched it by putting the 3 inside it, but it actually squished it horizontally. And so, what happened is sine completes a whole bunch of cycles and equaling a half, that's where 1/2 is. I end up with 1, 2, 3, 4, 5, 6 answers by the time you hit 2 pi. Actually, sorry, 2 pi was there. All right, so how do you actually do it? Well, do you remember me referencing a u substitution? I'm going to say sine of u equals a half, and that's meant to make the problem easier. You've done that like a whole bunch of times. In fact, you did it earlier this hour. But I should go off to the side. In fact, I have to say let u equal 3 theta. And at the end, your answers will have u's in them. And you got to remember, oh yeah, at the end, you take the u out and you put the 3 theta in. All right, so we'll do a u sub to solve this. So can I just skip the middleman and say, you know, we already figured this out, and this is pi over 6 and 5 pi over 6. You guys okay with that? All right, it'll save us a bunch of time. So u equals pi over 6, and u equals 5 pi over 6. Now there's 3 different ways you can ask the question. One is, what are the answers between 0 and 2 pi? In which case I'd be done. These are the answers between 0 and 2 pi. What if I wanted all the answers? Then I just add plus 2 pi k. What if I wanted to do this stretcho problem? Then I have let u equal 3 theta, so now I got to go swap out the u's for 3 thetas. I'm just going to write it right on top. You can too. And I have to also put in that part. Man, I wish I could just move this over, but it's one thing that I really wish they would fix on explain everything, this program I'm using to record. So I can't just grab that and move it over. I can copy it, and then I can paste it, but it won't just grab it and move it over. You guys have a lasso you can use to do that. I don't. All right, so now I'm going to put plus 2 pi k. And if all I had asked was for all the solutions, I'd be done. But that's not the hard kind. The hard kind means that I have to find all 6 answers. And how come I know there's 6? Well, because I drew you a picture. There were 6 of them. Here's another way I can know. How many answers are there for this? There's 2. Do you remember circle trig? We almost always had 2 answers. Unless it was a quadrantal, and then you'd only have 1. But other than the quadrantals, we'd have 2 answers. Well, this has a 3 here. Take a wild guess what you can do to tell how many answers there are. You multiply it by, well, the 3 by 2, or the 2 by 3. So there was going to be 2 answers. I put a 3 in there. It times it by 3. There's going to be 6 answers. So what if I had a 5 in here? Well, there would have been 2 answers. Put in a 5 there, there'd be 10 answers. All right, so there's going to be 6 answers. How the heck am I supposed to get 6 answers out of this? Well, I would, first off, write my first answer like this, pi over 6, and I'd put it in a little answer box. And then I'd put 2 more empty boxes after it. Then over here, I'd put 5 pi over 6 and 2 empty boxes after it. Those are going to be your 6 answers. And I'm just going to add 2 pi k over and over again until I get all the answers. But wait, if I actually added 2 pi, it would be bigger than 2 pi? Of course. So why am I not going to add 2 pi? Because I need to do one more thing to get theta alone here. Yes, or multiply by 1/3 or divide by 3. You are right. If I multiply everything by 1/3, now my answer is theta equals pi over 6 times 3 is 18 plus 2 pi k over 3. And the other one is 5 pi over 18 plus 2 pi k over 3. But wait, I thought it was pi over 6. Well, I was wrong, because I hadn't solved for theta yet. So it's not pi over 6, just change the denominator to an 18. It was pi over 18 and 5 pi over 18. That was just an oops. And now last thing, to actually add this, do you get it's going to be a pain in the butt since they don't have a common denominator? Pi over 18 plus 2 pi k over 3. Wouldn't it be so much easier if I times this by 6? Is it legal to do that? Sure, I'm multiplying by 6 on the top and the bottom. So then that means what I'm really gonna do, and I'd recommend you write this down, is I'm gonna multiply everything by, add 12 pi over 18. I'd be like, that's dumb. I'm just gonna add 2 pi k over 3. Cool. Adding 12 pi over 18 is way easier because it has a common denominator. And don't have to reinvent the wheel here. It's going to be the exact same thing. So you're going to add 12 pi k over 18. So I'm just going to change it to 12 pi k over 18 right off the bat. 6 times 3 is 18, right? And I know it could be reduced, but we don't want it because we want to keep it have a common denominator. So every one you do just keeps on adding 12 pi over 18. Here too. 12 pi over 18 gets added. And again. All right, so let's get the final answers. Carrot, when you have 1 pi over 18, like this, and you add 12 pi over 18, what do you get?
You get 13 pi over 18.
13 pi over 18, and then add 12 pi again.
You get 25 pi over 18.
25 pi over 18. Now, I ask, why can't I just keep on adding 12 pi over 18? Like, I'll add another one. I'd have 27 pi over, 37 pi over 18. Do you get that's bigger than 2 pi? So that's, you can't do that. Because we only want the answers between 0 and 2 pi. Question?
Why are you adding like the k?
The k is just how many times do you want to add 2 pi? The reason it's called 2 pi k in the first place is, back to this, sine wave, hits a whole bunch of times. If you get an answer here, we're going to add 2 pi to go over here. So why don't I just say add 2 pi? Because you want to do it as many times as you want. So you can add 2 pi once, or you can add 2 sets of 2 pi, Or you can add 3 sets of 2 pi, or 4 sets of 2 pi, or k sets of 2 pi. So 2 pi k. K is how many times do you want to add 2 pi. All right. So I'm going to add these two now. 17 pi over 18. And add 12 pi over 18 again. 29 pi over 18. There's my 6 answers. That is the second hardest problem on the test. That's not the question, of course, from the test, but it'll be like that. What do I think is the hardest problem on the test? I want to practice one of those. First off, we got to be able to handle it when there's a variable in there. Inverse sine of 1 over m. Can you draw me a picture of that? Because then you're going to find tangent of that. This is not the hardest problem on the test. This is leading up to. So if you can't do this, you wouldn't have any hope. So I have to do this to kind of warm you up, and then I'll show you what I think the hardest problem on the test is like. By the way, just in case, I'm talking about the test a lot. It's not tomorrow, it's not the next day, it's Thursday. Test is Thursday. Yes?
Turn this off.
Yes, you may. Better just unplug it. All right. Okay, so do you remember what inverse sine means? It means we want an angle. It means sine of some angle is 1 over m. And you draw a picture of that. Where do you draw them when they have variables? Nope, just one. If it's got a variable, always do it in first quadrant. You're right that there's 2 quadrants that sine could be in, this one and this one. Inverse sine's only allowed here to here. But when there's a variable, you only have to do one. And it's in first quadrant. Sine is opposite over hypotenuse. Do I need the third side? Yeah, I do, because I'm going to have to do tangent. So you always find the third side. Graham, what's that third side? Square root of?
Square root of 1 squared plus x squared.
Nope. First of all, it's m. Second of all, we are not on the longest side, so you don't add. So then you got to figure out which of the two is bigger. So Graham, I can step you through this pretty easy. What's bigger, m or 1? And then don't forget to square them both, and I bet you got it. A squared plus b squared equals c squared, so square them both. Got it, Graham? Or no?
No.
Okay, I'll take you off the hot seat. Alex, you know what's here? Can you find the third side? I don't understand why this is so confusing.
Square root of x squared minus 1.
Yep, it's just not an x, that's all. So it's an m. I swear I heard. Okay, fine. I thought I heard x squared. Okay, m squared minus 1. There we go. Have you guys forgotten how to do that? Is it a bit too long? Okay, I'm gonna do that off to the side again. We need to be like, that's got to be like super easy. If that's 8 and that's m, what's this side here? 64 minus m squared. That's got to be like easy peasy. Okay, what's going on there? Biggest side first. And then only if you're on the longest side do you add them. So let's say this is x and this is 5. This is square root of
X squared plus 25.
yes. Okay. We've got to find that third side in the right triangle really fast and easy. Okay, so we practiced it, so now I think you're good again. So now I think that maybe you understand why that's square root of m squared minus 1. 1 squared, but that's still 1. Then the whole point was to find tangent. So tangent, using this, TOA, opposite over adjacent. Final answer? 1 over square root of m squared minus 1. Okay, so that was hard enough. But what if that was in the middle of a cosine of 2 theta problem? But it wasn't cosine of 2 theta, it was cosine of 2, and then the theta is given by one of these. I'm going to use the word arc because some people are going to be like, what? It's the same as inverse. Arc sine negative a half. See, that's an angle. Why does this get extra hard? Well, we already did this. That's not that hard, but it's like the whole first part of the problem is inverse trig. And then you got to do this, which, do you have those memorized? Do you know what cosine of 2 theta is? See, this is cosine of 2 theta. That's like the theta right there. So this is like cosine of 2 theta. So I have to even look that up. It's on the sheet. And there are 3 choices for cosine of 2 theta. I'm going to personally pick this one. Cosine of theta squared minus sine of theta squared. Cosine squared minus sine squared. That comes right off the sheet for cosine of 2 theta. And if you can use this to figure out your angle, can you even do inverse trig? If you can. How many answers will there be for that? Isn't there like 16 answers plus 2 pi k? No, this is inverse trig. Do you get inverse trig questions? Have how many answers for that? Oh man, you guys haven't memorized the stuff I've told you. How many answers are there for inverse trig? One. One answer for any inverse trig problem. All right. The other ones can have unlimited answers, but inverse trig, only one answer. Okay, so then there's only one answer for this, so go find it. And then you'll be able to, once you've drawn your little triangle in the right quadrants, because sine isn't going to work here or here because, wait a minute, I'm wrong. Inverse sine's only allowed here and here.
Isn't that inverse cosine?
Oh, you're right. Thank you. Inverse sine is allowed. Good catch. Inverse sine is allowed here to here. So then I'm crossing off this, crossing off that. And now one more of them gets crossed off. I'll let you finish. You should be able to do this from here. But I get it's a hard problem. Like I said, it's the hardest problem on the test. It's like this, where you involve the sheet, where you have to look up stuff like this. And you involve inverse trig, so you got to be able to do stuff like that. I'll pause for a minute. We give this a shot. Okay, so hardest problem of them all. First off, you just have to draw yourself little triangles here. Sine is opposite, hypotenuse, square root of 3. Oh yeah, there's, oh wait though. This is where I recommend you always do this. Sine of some angle equals negative 1/2. Sine won't be negative there, so that one's out. So then I draw it down here. Sine is opposite, hypotenuse. One's negative, there we go. There, and what's across from the one side? 30 degrees, AKA what radians?
11 pi.
Oh, when you're doing it in circle trig, we're in the negative zone, so negative pi over 6. Now, the bigger question is, what is cosine of it squared and sine of it squared? Because see, we used this to figure out the angle, but then if I was going to try to get cosine of 2 theta, I would go to the sheet, write down what it is, which I did right here. And then I'm trying to figure out Okay, how do I get cosine squared? From the drawing you just made. Cosine of that angle, the angle in question, is this angle right here, negative 30 degrees. Cosine of that is adjacent over hypotenuse, which is root 3 over 2. Minus sine of that angle, opposite over hypotenuse, negative 1 over 2 squared. Okay, so that is 1/4. That is square root of 3 times the square root of 3, which is square root of 9, which is 3, over 2 squared is 4, minus 1, negative 1 squared is going to be 1, over 2 squared is 4. Ooh, sweet. And that just works out to be 3/4 minus 2/4, which is 3/4 minus 1/4, which is 2/4, which is a half. And the answer after all of that is just a half. Garrett, hold on just a minute, because we're about to show you what you need to do for practice for tonight. So, I'm not going to make you do proofs again, but that's one of the things we did with the sheet. You know, we changed cotangent into 1 over tangent, and tangent is, of course, tangent. And then you'd times by tangent over tangent to get a common denominator. And then you'd have tangent squared plus 1. And what is 1 with the tan? The 1 with the tan is what you seek. It brings in the secant, and there's a secant in the answer. And so I'm just reminding you what those are like, but we're not going to make you do. So I taught you earlier how to do this with a u substitution. Remember? You'd put in a u for that. And then you get the two answers. U equals the one thing and u equals the other thing. And then don't forget to put plus 2 pi k. And that would give you all the solutions. So if they want, what are all the solutions? You'd be done. The hardest of them all, probably isn't even on tonight's homework, it'll be on tomorrow's, is the kind where you have, oh, but wait, I only want the ones that are between 0 and 2 pi. Normally there's 2 answers for this, but we tell it a 2 there. That makes it 2 times the 2, which would be 4 answers. That's the hardest kind, but we're probably not even going to do that on the homework. All right, so here is a typical, like if I was going to do more practice problems, this would be it. But again, I want to keep today's lesson not terribly long because a lot of kids are absent. So we're going to go right to the homework. I would recommend you do the 2 that are circled there. Notice it's cotangent. Don't freak. Just rewrite the problem as tangent. Remember how the deal where if you switch this to 1 over that, then you got to flip this? What I'm talking about? If we change cotangent to tangent, you got to flip this over. And then on this page, this is just too hard. This one's not too hard, but it uses something that has been rationalized, and that confuses people. So I think we should do these 2. And we started the hour with one like that. Remember how you take square root of both sides? Don't forget how there's 2 answers. All right, and that's it. The next page has valuable problems, but I'm going to teach you how to do them tomorrow. Okay, so just try to get into your homework today and get it up through this page. And I think I've given you 4 problems. That is doable. This one, I get people get confused. Start by dividing by 2 on both sides. And now all of a sudden, do you get how it's root 3 over 2? And then make this into a u. Do a u substitution. And this, cosine of u is root 3 over 2. That would have been like, oh, that's super easy. I'll get my 2 answers off the unit circle. But then you have to substitute all that back in for u and solve it. It's not impossible by any means. It's definitely one of the hardest problems in tonight's homework, and you should definitely practice it. And the answer key is posted. Do a u substitution on number 12. All right, that's all I have for you for the video for today.